Hello everyone, and thank you for joining us today for our HexaBase webinar. My name is Chris Martin. I am a product manager at SRW Products, and I'm excited to discuss our new base replacement system, HexaBase. We're going to take a look at a few different topics today, discussing the function and key features of the base system under your projects, how it works, what makes it an essential part of the overall installation, as well as how HexaBase can be used to provide the same key functions of a traditional base system while saving the installer time and money. We're also going to look at a few other uses of HexaBase that really sets it apart and makes it a true 3-in-1 reinforcement solution. Let's get started. The idea of using different aggregates to form a stable foundation under paver surfaces isn't really that new, but it has certainly changed throughout the years. For as long as interlocking concrete pavers have been used, the technology and standard practices for constructing the base systems have been continuously evolving. As we have gained a better knowledge and understanding of how different aggregates and materials work together and interact for more stable foundations, we have found innovative new ways to engineer long-lasting paved surfaces with ever-increasing efficiency. This method of using different materials and aggregates to provide structure dates back to as early as 312 BC, when the Roman Empire began construction on a road network known as the Roman Appian Way, by layering different sized stones to form the earliest compacted base systems. This engineered aggregate base idea became the working theory for how interlocking concrete pavers are still installed to this day. Naturally, with new technologies and advancements in aggregates and especially geosynthetics, we're doing things a little differently than they did in the Romans' days. However, many of the same core principles of how they designed and built their roads are still in use today. The Romans engineered this base system to be permeable, meaning the base allows water and moisture to pass through gently instead of running off or becoming trapped just under the surface. It is designed to be solid by using specific size stones layered in courses of decreasingly sized pieces to interlock the entire base together, making a solid foundation regardless of the native soil quality. And most importantly, they designed these roads to be permanent. It may look like overkill in the graphic, but constructing the aggregate base in this manner is why many miles of the original Appian Way are still intact today, over 2,000 years later. As technologies increased and concrete pavements became more popular and more available to the masses, installers and organizations began creating a standardized method for constructing the aggregate base that would be installed under these projects. Building on the long-standing key principles developed by the Romans, the traditional base system that's been widely adopted and used since the 1970s is essentially a direct descendant of those roads that were built over 23 centuries ago. Let's take a look at the different working parts of a traditional base system. To start off, we have the compacted native soil. This is the soil on the job site that gets excavated out to make room for the base. Next, we have geotextile layer used for stabilization and separation. This geotextile or fabric is going to keep the particles of the base aggregates from migrating into the native soil below. Next is the aggregate base itself. This layer is installed and compacted together to interlock all of the particles into tight contiguous structure. This is the majority of the strength of the traditional base system. On top of that is a layer of coarse-grained bedding sand. This is used as a resting bed for the pavers above, while allowing moisture to drain through and away from those pavers into the aggregate below. The paver restraints or edging, which is installed along the sides of the pavers, help prevent movement from any of the pavers and breaking interlock. The concrete pavers themselves, and finally the jointing sand to provide the interlock that keeps everything from moving. To show the influence the Romans had over how we built our paver projects today, let's look at the two systems side by side. On the bottom you have the compacted native soil, followed by the compacted and interlocked layers of aggregates. On top of the aggregate, we have a finer mix of sand or crushed aggregates to form a bedding layer. We have the same concept of a paver restraint to keep the pieces from moving. On top of the bedding layer are the pavers or slabs, and of course the jointing sand to fill the gaps and prevent movement. These two systems may look vastly different, but they operate on the same ideas and theories. So I keep bringing up the principles and working theories of the base system and why they are so crucial to the overall project and ultimately its longevity. We're going to focus in on two of the most important principles that make the traditional base system work. The first is water infiltration, or the ability for water to pass through the system. Because of how the traditional base system is designed, moisture can easily pass through the bedding sand and aggregate bases instead of being trapped or causing ongoing issues. Some of these issues may include efflorescence, sealer blushing, freeze-thaw heaving, and a host of other undesirable problems that are all influenced in part by trapped moisture. The second key principle of how the traditional base system works is load dispersion. This works on the physics of how a compacted aggregate base system allows large load forces to be dispersed through the aggregate and spread over a large area of native soil. Essentially, as a load is applied to the paved surface, the force vectors going through the base material cause the pressure to be dissipated over a larger area and therefore reduced. Let's say we have a 6-inch aggregate base, and we apply a load of 2,000 pounds per square inch to the surface. The load vectoring may see a pressure of only 8 to 15 psi on the native soil below. That load was dispersed from 2,000 psi to less than 15 by the aggregate base system through load dispersion. These two principles, water infiltration and load dispersion, are among the most important reasons why the traditional base system has been recognized by organizations as installers to be the industry standard over the past several decades. So, where does SRW HexaBase fit in? With modern advancements in geotextiles and geocellular confinement systems, it has become possible to virtually eliminate the need for traditional base systems in certain applications without ignoring those two key principles: water infiltration and load dispersion. Now, there are still times, specifically when vehicular traffic is introduced, that aggregate base is needed. But for non-vehicular paver projects in both residential and commercial applications, a new approach can be used. SRW HexaBase is specifically engineered to save the installer time and money without sacrificing the strength or permeability of the traditional aggregate base. The first step in our design process was strength. The honeycomb structure is one of nature's strongest designs, and it's the backbone of SRW HexaBase. Using a honeycomb-shaped cell, we can create a design with minimal density while maintaining relatively high compression and shear properties. This is why honeycomb designs are sought out specifically for their strength-to-volume ratios in industries like automotive racing, aerospace design, rocket substructures, and even the mirror support structure for the massive Hubble telescope. Material selection is also critical to generate the robust strength needed. That's why SRW HexaBase uses 100% virgin high-density polyethylene combined with the honeycomb design to achieve a 327 pound per square inch panel bearing capacity. That's over 47,000 pounds per square foot of compressive strength. By using 100% virgin HDPE, we ensure nothing but the highest quality materials are used to manufacture SRW HexaBase panels. The next step was to consider permeability. SRW HexaBase is designed with a 97.8% open footprint to maximize water infiltration through the system. Moisture is easily evacuated through the panels and base material into the native soil below using the same principles that are found in the traditional base system. Some of the benefits of the free-flowing HexaBase system include reduced moisture retention, which will drastically reduce the chances of freeze-thaw heaving, reduced likelihood of sealers either blushing or failing, If using polymeric sand, you'll find that it cures better as a result of proper drainage. And finally, significantly reducing the risk of efflorescence blooms on the surface of the concrete pavers. The final step of the design was to create a product that was easy to use and install. SRW HexaBase utilizes interlocking male and female tabs that positively locks each panel together, minimizing flex. Starting in the corner and working outward, the installer easily slides each panel into position, exposing the tabs for the next panel. Best of all, the entire HexaBase system can be installed without the need for heavy equipment. HexaBase requires significantly less excavation than traditional base would need and can be easily accomplished by hand as opposed to needing a skid steer for the excavation process. This allows HexaBase to be used in projects in tight urban areas where heavy equipment may have a difficult time getting into those project areas. Let's take a look at the installation process of HexaBase. First thing you're going to want to do is survey the intended project area. Things to look for is how does the project area slope? What would need to be corrected for proper rainwater mitigation? Are there any structures or foundations adjacent to the project area that need to be considered? Also, how does rainwater naturally flow around the project area? After you've thought out the project area, mark the area and begin excavating the entire area down to the total depth needed. To figure out the total excavation depth, simply add the thickness of the pavers, or whatever paved surface you're using, plus 3/4 of an inch for the bedding sand. This is the thickness of the sand after paver installation and compaction. Plus, we're going to add 2 inches for the thickness of the HexaBase panels themselves. So, if you're using standard 2 3/8 inch paver, you would need a total excavation depth of about 5 1/8 inches. When digging out the area, be sure to properly slope the area for water runoff. The finished project should slope away from any buildings or structures. Be sure to excavate the area at least 6 inches larger on each side than the final paved surface, with the exception, of course, for structures or foundations. Lastly, be sure to clear the area of any tree roots or large stones that could cause uneven settling over time. After you've excavated the entire area and raked it flat, compact the area with a plate compactor. Take extra care to ensure the native soil remains as flat as possible and stays properly sloped during this step. The final slope of the paved surface is largely determined by the flatness and slope of this final prepped and compacted area. Next up, we're going to install the separation geotextile. The separation geotextile, or fabric, is a key component to the longevity of a project. This is because the fabric minimizes migration of particles between the base material and the native soil. This particle migration is one of the main causes of premature base failure under pavers. A number of different fabrics may be used for this step, but with the HexaBase install, the 2 main properties to consider when choosing your fabric are going to be high water flow and good filtration properties, or how large the openings are. We have found that the SRW products NW4, a non-woven, and the SB3 fabric, a lightweight spun bond, are perfect choices for this application. In the install photo shown on the right, we used SRW SB3 fabric for its ease of use and great water flow properties. Roll out the fabric over the entire project area. Make sure you overlap the fabric 12 to 18 inches at any seams, and that you run the fabric up any structures or foundations about 4 inches. Secure the fabric as you go with standard 6-inch landscaping staples. When stapling, make sure you pull the fabric taut and remove any wrinkles or bunched up areas. To install the HexaBase panels, simply start in the corner of the project, laying out and connecting each of the panels together as you go. The first panel installed should have both sides of the female connectors facing towards the inside of the project or where the next panels will be joined. Placing the first panel properly will allow each additional panel to easily slide in and interlock with the adjacent panels during installation. Continue until the entire excavated area has been covered with HexaBase panels. For any areas where the HexaBase panels need to be cut or trimmed, use of a handsaw or even a powered circular saw can easily and safely cut the panels to the proper size or shape. For our installation, the circular saw we used had a 7-inch diamond blade installed for trimming pavers and gave a nice clean cut through the HexaBase panel as shown to the right. Always use proper safety precautions when operating power tools. Quick pro tip: if you're working on a smaller installation and the HexaBase panels are wanting to move around on the fabric, put a few 6-inch landscaping staples into the cells of the HexaBase. Make sure when you put them in that the staple cradles the support webbing of the HexaBase as shown in the picture. Now it's time to install the base material. A HexaBase install can use up to 75% less base material than a traditional base system. Using a compactable base material, fill the cells of the HexaBase panels. Almost any compactable base material may be used, such as 3/4 inch minus road base material, crushed limestone, or even quarry processed stone. To estimate how much base is needed for your project, use the ratio of 1 cubic yard of base is equal to 100 square feet of finished project area. Spread out the base material, overfilling the HexaBase cells by roughly 1/4 inch. This extra material is needed to account for compaction of the base into the cells. Compact the base material into the cells using a plate compactor, making multiple passes and even compacting in the perpendicular direction to ensure proper and complete compaction. It may be necessary to refill some areas with more base material and compact a second time to ensure the cells are completely full. This is what properly filled and compacted HexaBase cells should look like. Now we install the bedding sand in the same way we would with a traditional install. Lay out your 1-inch screed pipes directly on top of the HexaBase cells, and using a straight board or similar, screed the bedding sand to a uniform thickness of 1 inch using the pipes as your guide. As recommended by ICPI, the bedding sand used for paver applications should be in accordance with ASTM C33 or CSA A23.1 specification. Begin laying out the pavers in the desired pattern and configuration directly on the bedding sand, following the pavers manufacturer's recommendations. The HexaBase system has been specifically designed to be used with traditional edging products and spikes. On this project, we used our standard SRW Products Universal Paver Rail. Be sure to use at least 10-inch smooth or spiral spikes to secure the edging around the paved surface. Also, when installing the edging, ensure the spikes are being driven into aggregate-filled cells at least 6 inches from the edge of the HexaBase. After the paver edging has been installed and secured with spikes, typically every 1 to 2 feet, finish the installation by compacting the pavers, making sure to either use a rubber pad on your compactor or a sturdy woven fabric like SRW Products SS5. This will protect the surface of the pavers from being scratched. Lastly, install the jointing sand, either conventional or polymeric sand, according to the manufacturer's instructions. So, what is 3-in-1 reinforcement? SRW HexaBase is an innovative, time-saving solution to a traditional aggregate base under paver projects. But HexaBase can also provide outstanding structural support for many other applications as well, including grass or gravel pavers, temporary access roads or easements, utility cart or golf cart trails, even fire access lanes around commercial buildings. Grass and gravel pavers are an eco-friendly alternative to hard surfaces in areas where rainwater management is crucial. Grass or gravel pavers also offer a solid solution to temporary parking areas, whether large or small, where rainwater can easily migrate through the system into the soil below. HexaBase excels in these applications by offering outstanding strength, and a large open footprint for water to pass into the native soil unimpeded. Some typical uses for grass or gravel pavers may include temporary parking areas next to buildings or driveways for boats or RVs, event overflow parking in larger areas like fields or backyards, fairground or event venues that want overflow parking or even temporary parking lots. With a similar concept to grass and gravel pavers, HexaBase panels can be installed using either topsoil or gravel to easily build long-lasting, light-use roads for small utility vehicles or golf carts. The interlocking construction and easy-to-use panels of HexaBase will quickly form a strong and solid pathway that will resist rutting or washout throughout the seasons. These are the types of trails and pathways you would commonly find at golf courses, campgrounds, country clubs, or even larger resorts. Over the last several decades, fire access lanes have become a common integral design feature included in nearly all commercial building construction. These fire access lanes are areas of reinforced soil, typically using a traditional aggregate base where heavy loads can be driven next to a building to offer fire and emergency services. Recently, engineers and architects have been using HDPE panels to reinforce these fire lanes and emergency access lanes. HexaBase offers the robust strength and high permeability properties necessary to be a great cost-saving strategy for these types of installs. Typically, the construction details of fire lanes and emergency access lanes are designed by an engineer and can vary greatly from project to project. More information is available upon request for fire lane installs and similar types of applications. The typical install for grass or gravel pavers is quite simple. Begin by prepping the area by removing vegetation and large stones, flatten out that area, and lightly compact the native soil if necessary until firm. Lay out the HexaBase panels over the entire project area. Fill those panels with either soil or gravel. If using soil, fill the panels nearly full or even a 1/4 inch from the top, as this will protect the root structures of the grass from being driven on. If using sod, fill the panels completely to the top with soil and then install the sod on top. Gravel can be filled completely or even overfilled a 1/4 to a 1/2 inch for the desired surface. HexaBase offers time and cost savings in a variety of installs, specifically designed to offer unparalleled strength and water infiltration. HexaBase is a solid solution for base replacement under residential or commercial paver projects, eco-friendly grass or gravel pavement used for parking areas or light-use trails, additional strength and permeability in applications like fire access lanes and emergency lanes. Developed around the same core principles that engineered the ancient Roman roads 2,000 years ago, HexaBase is a revolutionary 3-in-1 reinforcement system that enables the installer to create more efficient and longer lasting products. Thank you all for your time today.